Hello, this is the final project for ETE 210 by Sam Gordon and Sean Sapienza. We've made a light sensing circuit that varies the speed of flashing LEDs that is controlled by a 555 timer and a Triac. So here's the circuit diagram that Sean drew up. We're going to be plugging into the wall, so our source is 60 Hz, 120 volts RMS. We're then going to a step-down transformer to take the voltage down for us. That is connected to the center tap to a full-wave rectifier using 4 diodes. Across the positive and negative of the rectifier we have a 470 microfarad capacitor, and that will smooth out the voltage and bring it up to about peak voltage. And so peak voltage is going to be one of the calculations we do when we do the calculations for the circuit. Here we have our 555 timer chip. This is just a timing circuit. This potentiometer represents the photoresistor we are using, and as the light decreases, the resistance increases, and that increases the time between the pulses of our timer. The output goes to the gate of a Triac, which will turn on and off the lights based on how dark it is. As the light gets darker, the lights will pulse on and off slower. Main terminal 1 of the Triac is connected to the transformer. Main terminal 2 goes to a series resistor, which is 1K ohms. Then we have our LED string, and that goes back to the common of our transformer. We also have this series resistor on our output to limit the current to the gate. And that's our circuit. Next we'll look at some of the calculations we did just to make sure that everything in the circuit is going to be working right. Our source voltage is 120 RMS from the wall socket. Our transformer ratio is 0.15 from primary to secondary. So the circuit supplied voltage will be our source voltage, 120, times our transformer ratio, primary to secondary, and then since we're using the center tap, we divide that by 2. And that gives us 9 volts RMS for our circuit supply. We want to find the peak voltage, so we divide that by 0.707, which gives us 12.7 volts peak. Next, we want to make sure that the Triac has the correct gate current. Our timer outputs a voltage of 10.9 volts. That was just something we measured. The current to the gate should be 4 milliamps or 0.004 amps. We then use Ohm's law, V equals current times resistance, and rearrange that, divide the voltage by the desired current, and we got 2,725 ohms. And just to be safe, we used a 2.7K and a 100 ohm resistor in series, and resistance adds in series, giving us a total resistance on the output of the timer of 2.8K ohms. Next, we wanted to make sure that the terminal current on the Triac was correct. The total voltage on the load is the peak voltage that we supplied, so 12.7 volts. Each LED uses about 2 volts, so the voltage of the resistor, which is in series with all of our LEDs, is going to be our source minus the drops across all of the resistors. Since they each drop about 2 volts, and there are 5 of them, that's 12.7 minus 10, and we have 2.7 volts across our 1K resistor. Then we use Ohm's law again. The current is equal to voltage over resistance, giving us 2.7 milliamps through the Triac from terminal to terminal. Now we're ready to build the circuit. And here we can see the circuit in action. We have the transformer That's just plugged into the wall. Then we have our circuit on the center tap wire here. We have these 4 diodes. That is the rectifier. We have the smoothing cap. Here's our 555 timer chip and our light sensor. Here we have the Triac chip, and we're coming from our source down here, and then it's going through the Triac here, and as the Triac turns on and off, it allows current through the LEDs. And you can see that when we cover up the light sensor and make it darker, the lights flash slower. We can also really cover it up and make it even darker, and then they have a very long time on and off. And that is our circuit. Merry Christmas, everyone.